Hi, in this tutorial we look at the reverse normal node in Bifrost. I will show how it works and how to visualize the normals. This geometry shows how the node handles different normals. We can display the normals, we can switch from point component to face component and to face vertex component. When we enable on reverse normals, you can see the normals flip and the RDH stay the same. For the selection, we can select the face using tag, invert the selection, or use an array of indices. In this example, I use a random selection from my random array selection. I show this node in another tutorial. Now let's see how the reverse normals works. To reverse a face, we need two steps. First, invert the winding order of the face vertex point, and second, invert the normals for this new order. To explain the winding order better, I create a small visualization with arrows. The arrows use the position of the face vertex point, and with the shift array, I shift the position to get the direction to the next point. I explain this node in another tutorial. As you can see, the real order of the face is 0, 1, 4, 3. When we invert it, it becomes 3, 4, 1, 0. But only changing the order is not enough. We also need to take the face vertex normals in this new order and invert them. Only this way the face is really flipped. When we invert the whole geometry, these two steps are enough. But if we want to invert only some faces, we need one more step. We must create new normals only for the select faces and build the correct normal array without duplicates or unused normals. I prepare a small visualization to show you the internal logic. Here we have three columns: face vertex normals, visited map, and face vertex normals indices. The visited map has the same length as the normal array, and all values start -1. It shows if a normal was used before. -1 means new, any other number means already used. We have two faces here. Let's check element 0 of the first phase. This normal was not used before, so the visited map has -1. This normal is new. We do this. Take the original normal, invert it, add it to the end of the array and save the new index in the face vertex indexes and in the visited map. The same thing happens for the elements 1, 2 and 3. So at the end of the first phase, we have 4 new inverted normals. Now let's check the second phase. Element 4 has the same normal index that was used in the first phase, so the visited map already has a value. In this case, we don't create a new normal. We use the normal that already exists and we update the index. The same thing happens for the next vertex. The last two vertices generate new normals. Now we have new inverted normals we don't use anymore, and update indices. For the next step, we just select the first phase. Here we can see the dirty normal array with the new and unused normals, the update indices, the compact array with only the normals we use, and the new clean indices. Because some normals are not used, we clean the array. We remove the normals we don't need, we make the array compact, and we create new indices for the cleaned array. This step is important when working with the select phase. Now we start building the node inside Bifrost. We import the reference geometry and move it a bit to the right, so we can see two versions side by side. Now we create a new compound for the reverse normals and display the result. Before we continue, we need to enable the internal Bifrost nodes. To do this, add this line to the Maya file. After starting Maya, the internal loads will be visible. We create a getDefaultNormals node, we connect the geometry component to the input, and set it as combo box with 3 options: point component, face vertex component. With point component, we see the point normals. With the face component, we see the face normals. With the face vertex component, we see the point normals again. To fix this behavior, we edit get default normals and update the face vertex normal section. Now we rebuild the face vertex normals face by face. We use get mesh structure for the number of the face and the face offset, and get indexed geoproperty for the face vertex normals and the indices. Now we create an iterate. In this example I use an iterate, but you can also use a for each or work directly with the nodes, without loops. The result is the same. Inside the iterate, I create the face indices, use them to get the normal indices, and then read the normal values. Each face has normal for each vertex, so the output is an array of arrays. We flatten it and replace the original array. Finally, the face vertex normals component works correctly. This is the end of the first part of the tutorial. I hope the explanation was clear. In the second part, we will see how to apply the reverse to the whole geometry. Thank you for watching.